Hi, this is Dr. K. Rajendra Prasad. I am working as a professor and head for the departments of CSE, Data Science and Cybersecurity. Today we have discussed one of the important topic is in the parsing. There is a top-down parsing. Actually, the parsing techniques are totally two types. One is the top-down parsing, one is the bottom-up parsing. So today class we will discuss only about the top-down parsing. So what happens in the top-down parsing is actually parsing is one of the important phase in the compiler design. Because of here we have to try for defining the some valid tokens. After the valid tokens, we should arrange the valid tokens according to the syntactic structure. At that time, we make use of this parsing is very important. So this parsing that can be done with two types. One is the top-down parsing, one is the bottom-up parsing. So what the top-down parsing is? Top-down parsing that can be viewed as the problem of constructing parse tree for input string. That should always start from the root of the tree, and then further we have to creating some other intermediate levels of nodes. Means that is possible by creating the nodes of the parse tree. With the order is particular order is the pre-order. So pre-order is one of the binary traversal. You have the idea about the pre-order. According to the pre-order, we should construct the top-down parsing. So here in the parse tree, nothing but I am giving some example. This is about the parse tree. Here we should follow like this. This is about the parse tree. So means here we have to go for this. This is the action for I think pre-order. So means we have to creating the some nodes of the parse tree is in the way is only for the pre-order. So here the basic idea of the top-down parsing is we should always start the construction of the parse tree by creating or by initiating the root of the tree. Then you have to come to the some other nodes of the intermediate nodes. Then you have to stop the process after creating the some bottom level nodes that is called as leaf nodes. This I think brief about the top-down parsing. So in the top-down parsing, you can also refer to another definition is finding leftmost derivation for an input string. Already you have the idea about the derivation is. Means any string or any variable that can be defines some kind of derivations. So then the variable is called as a non-terminal. So in the derivations we have totally for discussing two types of derivations, LMD and RMD, leftmost derivation and rightmost derivation. Because we want to derive any particular string from the given set of productions or from the given set of rules of the particular grammar, then we can make use of the some kind of derivations, leftmost derivations and rightmost derivations. In the case of top-down parsing, you make use of only for the leftmost derivation. So what do you mean of leftmost derivation? Nothing but your replacement of the string. Okay, you have to replace the string. That should be leftmost non-terminal. So means here we have defining many number of non-terminals on right side of the production. For example, I am taking the one example is E derives E plus E. It is a notation for using what the purpose is the addition of any two values. So in this case, addition of two values case, you should refer to as totally for this. I think we have the further derivation of the capital E. So totally for these are totally we are identifying two different non-terminals. In this non-terminal, what is the leftmost non-terminal is this called as the leftmost non-terminal. Okay, LMNT. So this what happens? The second is the rightmost non-terminal. This called as the rightmost non-terminal. So in the case of leftmost derivation, you should always make the replacement of what type of variable nothing but leftmost non-terminals only. So here you have to make a replacement of the some value where nothing but you have to make your replacement or you have to change some non-terminals with some other new values by taking their productions at which position nothing but the leftmost non-terminal. Then only those kind of derivations are called as leftmost derivation. So this is I think idea of top-down parsing. So basically top-down parsing nothing but you try to construct the parse tree from root of the particular tree to until we have to getting the some leaf nodes, means the bottom of the tree. So the way of construction the tree is I think we make use of some kind of binary traversal that is called as a pre-order traversal. Or so one more idea of top-down construction is that can be viewed as finding a leftmost derivation for an input string. So these are the basic steps you should follow in the case of top-down parsing. So here we have to take some example for understanding of clear understanding of top-down parsing is. So here before that the grammar, I think there should be some kind of free grammar considering the factors of left recursion and left factoring. Already we have to discuss these two topics in the earlier classes. Suppose left recursion is happen, after removing the left recursion, what the resulting grammar is. For the resulting grammar only you can apply the top-down parsing. Means any grammar point of view you can find out whether the grammar has the problem of left recursion or not. If there is no left recursion, directly you can apply this top-down parsing technique. Suppose the grammar have some problem, the grammar has the problem with some left recursion or left factoring. Such cases we have the ideas of concepts for what idea is how can eliminate, for what purposes how can eliminate the left recursion or how can eliminate the left factoring is. So after elimination of either left recursion or left factoring, then only you can apply the top-down parsing for the resulting grammar. So here in this example I am taking this is the grammar, okay. I think this idea is without any left recursion, or you can also consider as without any left factoring. Means before applying this top-down parsing, you must know the knowledge about how can eliminate the left recursion problem and how can eliminate the left factoring problem. Then only you have to get some resulting grammar. So you should apply that resulting grammar for what kind of parsing is a top-down parsing. In the case of top-down parsing, you already got some kind of grammar. Okay, you are assuming this grammar has without any left recursion or without any left factoring. So this is the idea about for taking the input. You consider for the what kind of parsing is the top-down parsing. When you give the input for the top-down parsing, you should take care about the grammar has no left recursion or no left factoring. These are the important two steps you should follow. So then you come to that. So what the action is, you try for generating the step-by-step process. It is a step-by-step process for generating some trees. Okay, you should start from the root node and you can apply. Already earlier slide we have discussed what derivation you can apply is leftmost derivation. Here I am showing the leftmost derivation with the shorthand notation is LM. LM it indicates the leftmost derivation. Okay, it is the idea of top-down parsing. Means, so here we should follow some sequence of steps or some series of steps. Okay, at each step, so you apply the mechanism is called as leftmost derivation. But in the solving, I am showing the leftmost derivation with the shortened notation is called as LM. And we go for how you start it. Okay, suppose I am taking what is the root node here. This E is a root node. Okay, under this root node, we have to creating how many nodes? Nothing but T and E dash. T and E dash means it is a non-terminal. It is second non-terminal. Okay, it is also non-terminal. It is also non-terminal. Here, what is the leftmost non-terminal is? This becomes okay leftmost. This becomes leftmost. So for this leftmost non-terminal, you are going to apply some replacement. Means what the T alternative is? T alternative is either this one. Okay, only for FT dash. Only for FT dash. Means in the first step is you try for constructing the expansion of that capital E becomes a T dash. After that, you can define as this for the leftmost non-terminal. Here only you make the replacement. Again, the T that can be replaced with F1 T dash. So means here this is the one step, this is another step. Like that you can apply the some series of steps. This is a process you should follow in the case of top-down parsing. So basically the objective is we try to constructing what kind of tree is a parse tree with the approach of some root node to some leaf nodes. So at each step of in the sequence of trees, okay, you make use of what kind of derivation is called as leftmost derivation. So we have to see these are the series of steps. Okay, initially I am taking this about the root node, and then I am applying what the E that can be derived as. Okay, you know E that can be derived as TE dash. Okay, so the same thing is expanded, it becomes TE dash. After that, so we have totally for two non-terminals. So what is the leftmost non-terminal is this is about the leftmost non-terminal. Then you should expanding T as FT dash. Okay, because of in the grammar already we have the derivation for capital T. T becomes FT dash. Means here also I am applying the LM. Implies LM nothing but you try to make an expansion. So using what kind of derivation is called as a leftmost derivation. So after that again we have 1, 2 and 3. Totally for 3 non-terminals again, which is becomes the leftmost nothing but F is becomes the leftmost. Already F has some kind of derivation. It has the derivation is called as ID. So you should expand F as ID. You should expand F as ID. So like that you have the some getting the clarity about what is the series of steps. Okay, at each step of I think this derivation you should make use of only for the what kind of derivation is leftmost derivations. So again we should revise what the topics we have following is top-down parsing. The second point in this slide, top-down parsing can be viewed as finding a leftmost derivation for an input state. Okay, so regarding to this, I think we have the grammar. We have the grammar with many non-terminals. You should try to construct some kind of parse tree. Okay, so in the case of parse tree, we have go for starting. This becomes I think starting variable. You are assuming this for the some root node. This for the root node. Okay, I have to go for root node, and I make a expansion of the E becomes TE plus. You have to check it. This I think idea of E implies TE dash. E implies TE dash. That is the expansion we have to refer. So as per the I think the given productions, and at every case, okay, you make a replacement is only for leftmost non-terminal only. You can apply only for this kind of mechanism, so that finally you have to construct it some kind of parse tree. Okay, this called as some kind of parse tree is generated. This kind of parse tree is generated using what approach is top-down approach. Okay, so means this result finally you have to got when you applying the some series of steps. At every step you try for generating the some kind, you try to expand the some tree with the idea of leftmost derivations. So at each idea of leftmost derivations, the tree will be expanded. So finally you are getting the one kind of parse tree. Actually it is for your aim or object of the I think top-down parsing. The object of top-down parsing is try to construct the some kind of parse tree in a way is using the leftmost derivations only. So these are the ideas I think regarding to the example of top-down parsing. In the case of top-down parsing, we use okay, especially for one kind of algorithm. The name of the algorithm is called as recursive descent algorithm. Recursive descent algorithm. So I think in the recursive descent algorithm, so very understandable steps are there. So here we have to see the production derives what are the non-terminals. Okay, here many non-terminals are there, x1, x2 and so on, xk non-terminals are there. So because of here I am trying to derive the I think this derivation from leftmost to rightmost. So first I am trying to make a what the value of x1. Okay, you are trying for x1 nothing but 1. You should started the for loop also started from the 1 to k only, right? So means here I am making a substitution of the first iteration. It becomes xi becomes x1, means because of among the totally for k number of variables, k number of non-terminals, x1 to xk non-terminals, you feel as what is the leftmost non-terminal is x1 always. So as per the logic also here we are getting the I equal to 1. So xn nothing but x1 it becomes I think it is one of the non-terminal, leftmost non-terminal. So for this we have to apply the, again recall the procedure of xi. So recall the procedure of xi nothing but you find what is the xi derives. You find what is the xi derives. So you make a substitution here. Suppose xi derives something y1 and y2 like that. Okay, because we have to call y1 y2. Again y1 it becomes the first leftmost non-terminal. Means this recursive descent passing mechanism is telling the logic of top-down passing with many number of recursive calls. With many number of recursive calls. At every recursive call, we try to solve the problem is in a way is leftmost non-terminal. Okay, you should remember this is the basic idea of recursive descent passing. This recursive descent passing that can be used for construction of the pass tree using the mechanism is a top-down passing mechanism. So here these are important steps regarding to recursive descent passing. Recursive descent passing consists of a set of procedures. So one for each non-terminal, and you should always begins with the procedure of for the starting symbol. Starting symbol is the starting non-terminal. This is available in the starting production and left hand side variable that is called as starting symbol. Using this called as some root node of the corresponding pass tree, and we have to stop the process when nothing but suppose your scanning process for the entire input string is completed, then you have to stop the process. So that is given in the third step is it halts the process when the processor scans the entire input string. And further I think I'm discussing, okay, it is good because of recursive descent passing that can be used for I think construction of the pass tree. Okay, using the way is the way is the top down approach. It is okay, but we have some problems with the recursive descent passing. The basic problem is backtracking. Okay, sometimes I think the required input string you are not achieved. The required input string is not achieved. In that case, you are going to apply again backtracking. You try for getting the solution. Okay, this backtracking mechanism I think it is not good because of we have to forwarding the I think steps from I think root node to some other intermediate level nodes and again leaf node. Again at the end again you feel as your output is not reached. Again you have to apply the backtracking. Again reverse the all steps. This is a time consuming method. So that's why I'm not recommending this kind of recursive descent passing. It is good, but come to the idea is construction of the pass tree using the way of mechanism top down. But I think why it is not good nothing but there is some problem with the backtracking mechanism. So backtracking is not a simple mechanism. I think the size of the tree is heavy. I think massive number of nodes and a massive number of branches, massive leaf nodes. At the time again backtracking to any previous I think levels is I think it will take some more time. It requires some more computational demands and also as well as memory demands. That's why it is not efficient, right? So this is a problem of backtracking is so we are discussing with the main keyword is backtrack. Recursive descent passing case, the main problem is you are facing with the backtracking. So this method is the backtracking, but you are getting the solution however. Okay, we use with the backtracking you are getting the solution. You achieve your expected input string. Okay, it will be matched maybe most of the cases. But the only thing is it's a time consuming process, so its parsing is not efficient. So this is a discussion about the recursive descent parsing, and we have to go for some good example regarding to the recursive descent parsing. Here I am taking 24 how many number of productions in this example, but 3 productions only. Okay, we have taken the 3 productions only. So I am asking the question is to construct the pass tree. What the approach we are taking is a top-down approach only, and for the input string is W equal to CA. So we have to see how can we are getting the approach of top-down and where I think backtracking is useful. We are getting that idea also. So for that case, I think how you solve the problem is for the using this grammar productions. Totally, I am taking the 3 grammar productions and try to achieve the matching input string is W equal to CAD only. W equal to CAD only. So first I am taking the starting process like this. Okay, I am going to solve this. I think we have the expression small c and capital E, A and small d. Okay, so here we have to go for the string is your expected string is CAD. So C is matched. Okay, I think not an issue. C is matched. Again you try for matching is small a, but here capital A is there. You go for what the capital is. I think using the production SC implies CAD. Okay, you are getting this is a tree. And again for the expansion, I think here what the A is. A suppose I am assuming A implies AB only. A implies AB only. So at that time, what the resulting is, you have to go for this resulting. Okay, CA and BD. CA and BD. Right. So means here we have to check it. The your output is CABD, but your required is CAD only. So you have to go for matching of this. Okay, and what is the matching is B is unmatched. Okay, so I think there will be some wrong. I think when you applying the some mechanism of substituting the leftmost non-terminal, some I think you are choosing the production is that should be wrong. So that's why here the requirement is you should apply the backtracking and you should record the problem. You should record the problem. So backtracking nothing but where I think wrong is here. Making the alternative is here. That should be wrong. That should be wrong. Okay, what is wrong is selecting A implies B is wrong. A implies B is wrong. So that is the reason. So again, I think you try for another alternative for this. Okay, the reason is I think already you know that A implies capital A implies small AB. I think it is wrong. So that's why you are applying the here backtracking. Backtracking is applied. Here I'm writing the backtracking is applied. Okay, this is the backtracking. This is the backtracking is applied. So after backtracking applies, I think you cannot go for again A implies AB. Now you go for with alpha backtracking step. A implies A. That should you select. That should you select. So now we have to check what the symbols are. C A D. Okay, here C is there and A is also there. Small d is there. Okay, our expected I think string is CAD. So this case both are to be matched. Both are to be matched. So it is for the I think your expected positive construction using the top-down approach. So here we are taking the applying the algorithm is called as a recursive descent algorithm. So in the recursive descent algorithm there is a provision, okay, for applying of backtracking. So where nothing but suppose your string is your expected input string is not matched, at that time you can apply the backtracking, and again you should recover the issue. So this is the way I think for solving the I think construction of the pass tree. Okay, using the mechanism is the recursive descent passing mechanism with the backtracking. What the advantage of backtracking is, sometimes the string is not matched. You want to go for the previous step, that is the idea of backtracking. Again, you have to reselect another alternative of the particular corresponding non-terminal, and again you have to try for getting the answer. So I think these are the ideas for the top-down parsing. And similarly, we have another example. Okay, so this is the left for you. This example is, and here I am taking totally for how many productions are. I think 5 productions. Easy type 5 productions, and we have to at end of the pass tree. When you matching the leaf node values of the pass tree, so you try for matching the string is MSQN. In such a way that because it is totally for the what kind of grammar is a context-free grammar. It is a context-free grammar. You know the idea of a context-free grammar. So context-free grammar is given. So I'm sure that I think here no left recursion. Okay, no left recursion, and no left factoring. No left factoring. And no issues about no left recursion, no left factoring. So directly you can apply the recursive descent parsing. Suppose any left recursion is there, you can apply the I think idea of how can eliminate the left recursion or how can eliminate the left factoring. You know the idea. You can apply these two concepts. Then again your grammar becomes no left recursion, no left factoring. So after confirming the no left recursion, no left factoring, then directly you can apply the recursive descent parsing. But fortunately here I think this grammar, this context-free grammar, so has no left recursion, no left factoring. So directly you should apply this recursive descent parsing. Suppose that some of the stages you feel as you are unable to get this kind of string. Okay, so you may apply the backtracking also, recursive descent parsing with the backtracking. Definitely you getting the answer. So this exercise is left for you only. Okay, with that we are getting some problem idea. Okay, how can getting the solution of this particular grammar using recursive descent parsing with the backtrack mechanism. Okay, so how you construct the pass tree for achieving this particular input string is MSQN. So means in today class we have discussing I think major topic is types of parsing. Here we have the two types of parsing, top down and bottom up parsing. but we should start with the top-down parsing. The basic idea of top-down parsing is we have tried to construct the parse-tree from root node, and we have to proceed some other intermediate nodes and also leaf nodes, and in such a way that finally the leaf nodes, okay, you have to matching the symbols of leaf nodes that will be matched with the given input string only. Here I make use of one particular kind of algorithm, is recursive descent parsing algorithm. So it is good because here also I think we make use of the simple logic is your replacement of your string that should be with a leftmost non-terminal only. So sometimes suppose you are not you are unable to match the given input string, so you may apply the backtracking. The backtracking idea also given in the recursive descent parsing. So means with the backtracking, I think most of the cases you try to getting the complete construction of the parse tree for any kind of input string. But only the problem of the recursive descent parsing is sometimes it requires okay, so more computation time when nothing but especially when you use the backtracking mechanism. So this is the topic of the recursive descent parsing. So this we have discussed in today class, and we have got these ideas from our prescribed book is I think Avisetti and Ullman, Compilers Principles, Techniques and Tools, PSN Education. This is I think a main textbook we have to refer. So we have to getting the relevant content from this reference only. So once again, thank you to all.
Like, share and subscribe. Hit the bell icon for more updates.